Okay. Alright, so hey, I passed out candy to be thankful, so the cell phones, that kind of stuff.
I apologize.
Give me your attention, please. Okay, so it goes translations, it goes reflections, and then it goes to rotations. If you remember that translations, reflections, and rotations, the word was called rigid motion. It means that the angles and the side lengths stayed the same. Nothing changed about it. So when I took a figure, did some kind of manipulation to it, and it came out over here, it was the same figure. The word that we use in the big idea in GOA, the first thing of GO, is congruent. They were the same. The angle measures were all the same. The side lengths were all the same. Now when we get into a dilation, we're not keeping that idea. We're actually, a dilation is going to change the figure. It's going to either shrink it or make it bigger. The idea is no longer congruency in GOB. The idea is similar. Are the figures similar? Meaning they have the same attributes. This is a square, that's a square. This is a triangle, that's a triangle. However, they share a relationship between the two. And so that's where dilation comes in. I don't really care about that. So dilation, we need to find a scale factor of dilation. Scale factor is the relationship. Yeah, I'm sure. So the scale factor is truly the relationship sharing between this square to this square. It is that relationship that's being built between the two. It's what causes figures to be similar. They have to share the same relationship. Within scale factor, within dilations, we have two things. We have a reduction or we have an enlargement. So a reduction, what do you think reduction means? Makes it smaller. The idea that we're going to get into is a reduction is always going to be less than 1. And that's going to make sense when we actually talk about scale factor. But for now, a reduction means that it's less than 1. It's getting smaller. So anything less than 1, 0.75, is that less than $1? Yeah, it's smaller. It makes sense. Like anytime I hear a decimal or change, I'm like, oh, that's shitty. But then I'm like, $50. I'm like, yeah, I'm the queen. I can buy anything. Which really I can't, but I think I can. So an enlargement is going to be greater. So since a reduction is less than 1, what do you think an enlargement is going to be? Greater than 1. The best idea of talking about dilations, because this is kind of where the word, either the word stemmed from or this is why the word is called a dilation, is how many of you guys have your eyes dilated?
Yeah.
I never have, because I don't have glasses. I'm looking at Antonio and I'm like, of course he has.
Don't your eyes dilate, like, say you're in a dark room and then
Yes.
you walk outside and they dilate by themselves?
Yes, they do dilate by themselves, but when you're talking about when you get your eyes dilated, it goes from this and like, all your whole eyeball is just a pupil. Like, screw seeing blue eyes or poop eyes. Okay, sorry you brown eye people. When your eyes are dilated, it goes from this pupil, this normal sized pupil, to this like huge. Your eye just becomes your pupil.
It's hard to see.
It's still a circle. Last I checked, that'd be really weird if your eyes dilated and your pupil became a hexagon. You're like, oh, that's some really cool eyeballs. Otherwise, it's still a circle. There is a relationship. There's truly an amount that the eye pupil dilated by. So an example of a dilation, just the idea, is your eye pupil. No, I just give a lot of space for it, who knows why. I'm weird, and I'll get out of your way. I'm so sorry. Eye pupils? Oh, can you not read that?
No, she's talking about
Oh, okay. Oh, I didn't care about those. I don't even know.
ERRG.
I don't know.
I don't even know what it is. There's some things I take out, and then there's some things I don't. And that was one thing that I was just like, ah, let's just give it. Okay. Now, let's actually get into the idea. So we gotta I put it over here. Okay. Let's let it not be that day. So, knowing that a dilation is something of a figure getting bigger or smaller, smaller, bigger, vice versa, which of these options show a dilation? Our skateboard. It goes from big to small. Or, depending upon how your brain processes pictures, because maybe with Angela going to Tokyo, did you actually go?
Yeah.
Okay. Do you process it that way? I don't know, maybe small to big? Or do you say big to small? I don't know. Maybe people process it differently. I don't know where I went to Tokyo. I'm off. I'm done.
I don't know. I just heard it be big to small.
That's how you see it? Okay, that's how I see it too. I just didn't know. You can do vice versa though.
Read the other
Yeah, if you read the other way, that's what I was saying. Like, I don't know if like people's minds process it this way.
Wait, are you talking about like reading it?
Yeah.
Oh, then you read right to left.
Okay, so it would be that way.
Yeah,
Small to big. Okay. So, regardless, it's the same. Just depends upon the direction that you are going.
No.
A dilation is going from big to small or small to big. Okay? And it says, when a figure is formed by congruent transformations, what is true about the corresponding angles and the corresponding sides of the image and pre-image? Remember, image is where you ended up. This is like what I got. This is my image. Your pre-image, pre means before. So the pre-image is before I did anything. Before I touched it, manipulated it, doesn't matter. So your angles stay the same. You spell angels. Through dilation. The word that we use for same, if we're going to talk mathematically, is congruent. So your angles through dilation stay congruent. That should make sense. If I give you, gotta give me a second. I'm going there. No, I wanted it to be precise. Antonio, okay? So if we're talking about a dilation between my sticky note here and my sticky note here, what can you tell me about those shapes? Okay, I don't care about the, don't tell me about it. What shape is it?
Square.
A square. And what do we know about the angles of a square?
90 degrees.
90 degrees. Is that true for my big guy and is that true for my small guy?
Yeah.
Yeah. So the idea is saying that your angles never change. That would be really awkward if you dilated and your square became a... It like rolled on top of each other. That's my angles. So it's not true that your angles get smaller. They stay the same. A square is still a square. It still has 90-degree angles.
An angle punch.
Okay, I'm getting there. That, my friends, is art. Okay? However, if we looked at our dilations that are no longer there, but what could you tell me about the side lengths?
Either increase or decrease.
They either increase or decrease, and this goes back to the word of scale factor. The side lengths, this is weird. Side lengths, 3/8, is that right? Is there an E at the end?
Yeah.
Ooh, that looks really weird. Side lengths create a relationship between all sides. So it is just like an equation. What you do to one side of a figure, you have to do to all sides. It has to be fair. It'd be really ridiculous if I was like, Jamie Lee, you're my favorite student. Not Antonio, because I burned his stick. You're my favorite student. I'm going to give you $20 because you're my favorite. And then I said that just to her, and she's like, oh yeah, I'm going to pocket $20.
So you call
Antonio
me
saw me.
now?
What?
I see how it is.
Yeah, she's not even my student. And she's like, over here, my favorite out of all of them. No, I can't do that. I have to be fair. And if Jamie Lee's my favorite, Alyssa's my favorite. Isaiah's my favorite. Anna's my favorite.
Yeah,
So the idea is that you have to be fair.
She got
What you do to
quiet
one
there.
side, you got to do to all sides. And I'm not saying sides of an equation, I'm saying sides of a figure. So if you have a 900-sided figure and I give you a value of 7, I have to make sure that every side gets that relationship of 7. I can't be like, all sides except my Felix get 7. Miss Jones is like, what? I got this big heel. I'm just gonna stay dinky. Okay. So let's actually talk about dilations. I explained it. I tried to get you guys to like visualize it, be a part of it. Let's actually get down to the nitty gritty. So, who's that? Is it Rasan? That sounds like a Rasan thing. That sounds like Rasan. So I'm assuming Rasan will show up somewhere. Alright, so a dilation. Reading the definition. A dilation with a center of C. So if you think back, rotations and dilations are very similar. You have to be dilated from somewhere. You can't just be like, dilation! No, somewhere has to be the starting point. And so you have what's called the center of dilation. And in this example, they said C is our center of dilation, which is right here. So C is the center of dilation with a scale factor of n. So that's cool. We'll get there. You can write dilations. I know you can't really see it right there, but dilations, the notation is D, N, comma, C. D stands for dilation, and N is the scale factor, C is what you're dilating. So ultimately it comes down to, if you think about it, when we had translations in a coordinate plane, it was big T. If we had reflections in a coordinate plane, it was big R. If we had rotations in a coordinate plane, it was baby r. So all of them kind of correspond together. The only one that's kind of hard is reflections and rotations. So anytime you see D, that tells you some dilation is going to be happening. Now let's actually take this and talk about the figure itself. So I'm going to erase that. Okay. So the first thing that we need to know, my first asterisk. Angles are preserved. Okay, that's cool. Angles are preserved. That means that angles stay what? What does preserved mean? The same. So you're keeping it locked up. Like when you put it in a Ziploc bag, it's hoping to not get any bacteria. It's supposed to stay good. Unless you put some other stuff in there, then it's probably gonna rot. So preserved means stay the same. So angles stay the same during a dilation. That's the only thing that happens within similar. Thank you. I really didn't know where I was going with that. That's the only thing that stays the same between similar figures is their angles. Now let's get into the fun stuff. The point of dilation. So where I'm dilating from, the point of dilation is itself. Meaning C is equal to C prime. So remember, your vertex C is what you start with. When you do something, when you manipulate the vertices, that's where you get your prime. So we have C prime. So that's always where we ended up. Something was done to it. Why would C be equal to C prime as my point of dilation? What does that mean if they are equal to each other, equal to themselves?
It's the new or the new point or whatever.
Okay, it's the new point. Were you gonna say something? Okay, I overheard you, so I just want to make sure. It's the new point. Okay, you said you stayed the same, but you added something to it. Is that what you said?
Yeah, like do more stuff.
You added a prime. Okay, so it stays the same, but you added more stuff to it. Okay, yeah, I wasn't following it, but I was gonna repeat it. Thought you were good. The idea C is equal to C prime. The reason why it's equal to itself is it's the center of dilation. That means it doesn't move, right? If I'm gonna rotate myself about my point. Oh, sure, I have a bunch of them. Do you want to do it? Yeah, okay. So, I'm thinking you want for your class, right? Yeah, one pair of scissors for the whole class. That sounds good. Share, take turns. The reason why the point of dilation is itself is because that C is equal to C prime. It's meaning that point of dilation never moves. Doesn't that make sense? It's a point of dilation. That's where I'm getting dilated from. That's where everything's sprouting out from. Did I ever move when I go like this? My arms are my dilate. That's just like me explaining my motion. You know, like when you're running and you used to show like little dashes next to someone and you're like, they're moving, right? And you're like, dash, dash. That's me showing my motion. Did I ever move? No. So the reason the point of dilation is the same, it's saying that that point is fixed. It's never going to move. They're literally equal to themselves. Okay? It's really not a big deal, but it's a cool idea to know. Last thing, scale factor. This is our relationship. Scale factor is what you are multiplying your figure by to increase it or decrease it. So you know how I told you guys reduction is less than 1, enlargement is greater than 1? That's talking about scale factor. If my scale factor is less than 1, my figure is going to get smaller. If my scale factor is greater than 1, it's going to get bigger. So scale factor, there's a formula for that. I call it SF for scale factor. The formula for scale factor is prime over original. And I'll give you kind of a little in parentheses, I'll kind of give you layman's terms what that means. Prime is where you ended up. Over your original is what you started with. So where you ended up over what you started with. That is scale factor. Prime, the reason why it's prime is because you did something to it, remember? So if I was A and I translated, I slid it to the right, I am now A prime because I did something for it. My original me is right over here. I'm no longer Mrs. K, I'm Mrs. K prime because I came over here. So the reason why it's prime is where you ended up is because I did something from the original. I moved somewhere, somewhere. Okay. Let's use it. Let's actually get into the fun stuff about scale factor. Okay. So finding scale factor, we're going to use this figure right here, and we're going to find a couple things based on the directions. It says, is the figure an enlargement or a reduction? And what is the scale factor of the dilation? Yes, I understand that my figure is black and then blue. Yours is dark and then gray.
It's a reduction.
Okay? And you are always going from your original vertices, A, B, C, D, everything that's just itself, to its primes. So A prime, B prime, C prime. So our original figure is going to be X, R, T. Because those are all my original vertices. When I do something to them, that's when they get their primeness. I did something to X to get X prime. I did something to R to get R prime. And I did something to T to get T prime. So now, if we start on XRT and do something to get X prime, R prime, T prime, did R do something? Did it get bigger or did it get smaller?
Bigger.
It got bigger. It went from R to R prime, T to T prime. Why R?
The center of dilation.
Perfect. The reason why X prime is equal to X is because that's our center of dilation. It's not a big deal, but going back to the idea that a value and itself are equal, we know that must be center of dilation. So comparing your image, that's your primes, to your pre-image, that's your original, that's the stuff that we started with. You guys told me it got what, bigger or smaller? It got bigger. What do we call bigger? What is our mathematical term for bigger? Enlargement. So now that we know that we're dealing with an enlargement, we know our figure is getting bigger. What did we talk about the scale factor? Scale factor has to be what in order for it to be an enlargement? Okay, that's the formula for scale factor. Good for you. Has to be greater than 1. That means our scale factor has to be greater than 1. So now we can check our work. We know that it has to be greater than 1. So if we end up getting 0.5, we automatically know that, okay, that's not right. I know if I have an enlargement, it has to be greater than 1. Are you okay? No, you're not okay? Okay, just want to make sure you're good. So it says, what is the pre-image length? Pre-image is where we started. So
Passing time has Teachers and students, please, no more students
Okay.
out of class now before 1:40.
Doors open.
Thank you.
So, the pre-image length is going from, pre-image is where you started from. It's the length from our original triangle. What is the length of my original triangle? 4.
And you divide it.
Okay.
Yeah, since it's over, like
And then once the image.
Oh, hold on. What is the image length?
8.
8.
Okay, the image length is saying it's going from, okay, let's do it this way. Our length from our original triangle is xt. We now want to go to our image length, which should be x prime, t prime.
Oh shit.
So we want to go here to here.
Yeah.
So what did you do to get 12, Brayden? You add it. 4 plus 8. What's 4 plus 8? 12. So our image length is going to be 4 plus 8, just in case if you don't decide to write everything that I do. 4 plus 8 is equal to 12.
Scale factor 3.
Why did you put negative?
I didn't put negative 4.
I'm blind.
You can come right here, Isaiah. Do you want me to move this?
That doesn't even.
No.
How am I knowing you're going like this with your hair?
I think I will.
Is that why you left to go fix your hair for Isaiah?
I'll have to go.
Oh. I was like, really? I was like, wow, you're nice.
Yeah.
So, before we finish and everything, the reason why we added these lengths is because the only time that we're going to add these lengths together is if they share a common side. I'm going to give you examples before you have the practice to kind of explain that and reiterate that. But the only time you're going to add up this length, that looks dirty. Anytime you're going to add up these lengths is when the side of the two lengths are being shared. So, meaning, I could give you a square like this, and then a square on the inside. Would I add those two lengths together? No, because their sides aren't going to be touching. So the only reason why they're touching is because they're ultimately sharing a common unit. Our original triangle was using a common unit of 4, and that 4 was also being used to our prime triangle. So that's why we had to add it. Okay, now that we know what our image length was, our pre-image length was 4, our image length was 4 plus 8, where Brayden told me that was 12. And then the last thing that we can do is plug it into the idea of scale factor.
Prime over original.
Prime, where you ended up, over my original.
So it's 12 over 4.
Perfect. 12 over 4. And can that be simplified?
Yeah, the 3.
Is 3 greater than 1?
Yes.
Do we have an enlargement?
You know it.
Yes. Okay. I don't know. My feet are hurting right now. I should bring some flip-flops. That's why I don't wear them, because I can only deal so much with them. Alright, finding a dilation image. So now here's going back to using the notation of dilation, using D. So it says, what are the coordinates of the vertices of D, 1/2, the triangle PZG? So D 1/2. The 1/2 is standing for our
Scale factor.
scale factor.
That's
That's
below 1.
It's below 1, so you can assume that we are going to have a
reduction.
reduction. So the center of dilation in this photo is going to be the origin. It's always going to be the origin when we're talking about coordinate points. And there, you asking a question? Yeah, me too. So the center of dilation is the origin, and the scale factor is 1/2. And going back to what you said, Amanda, what are we going to have? An enlargement or a reduction? We're going to have a reduction. Since it is less than 1, the dilation is going to be a reduction.
Oh my gosh, I'm gonna hear this.
Yes.
Can I go 30?
Go already?
30? Just for today?
Yeah. What time early?
Like right now? Because I gotta go to work.
That's fine. When the videos popped up, I'm going to give you the link how to do it. Getting the notes and understanding it's on you, okay? Cool. Yeah. All right. Fill in the coordinate points with the given vertices. So now what I want you to do is use our values from our graph to fill it in. That's not supposed to say Q, that's supposed to say Z. I know how to use the alphabet, I promise, just not today. So what is our coordinate point for P on that graph? 0, 2. Our coordinate point for Z? Negative 3, comma 1. And then our coordinate point for G? 0, negative 2. Okay. Now the idea of scale factor given our notation, d1/2 xy. And then it kind of tells you how it's used. Do you see how 1/2 is distributed to the x and the y?
Yeah.
That's literally what scale factor is. It's a distribution. You're going to distribute the scale factor to every coordinate point, x and y for every coordinate point. Not just x, not just y. We have to be fair for everybody.
Multiply the x and y.
Yep, you multiply your x and your y. So I'm going to erase this. I'm a stepper. I know some of you guys are like, okay, I get it. And I'm like, oh, that's okay. I'm a stepper. So we're going to take the dilation of 1/2 of P. Our coordinate point for P was 2, comma 0. So now we're going to take the dilation of 1/2. What's 1/2 of 2? What'd you say? 1. Okay, I want to make sure I heard you right. So 1/2 times 2 is 1. What's 1/2 times 0? 0. So P prime is 1, comma 0. For Z, our coordinate point for Z was negative 3, comma 1. 1/2 times negative 3. What's half of 3? 1.5. So it would be a negative 1.5. The reason I know that is if I had $3, split it up to my son and my husband, because I give them allowance, not my son, but my husband I do.
You give him an allowance?
Yeah, like a weekly allowance. Like what he's able to use. That doesn't sound bad. That's what, like, I get an allowance. That's where we are able to do whatever we want with.
Oh, like you
Oh,
guys
like an
split your
envelope?
guys' money, so like you go get your nails done, he goes and buys like whatever.
He spends it on food. Yes.
Yeah.
Yeah, that's what I use to get my hair done or my nails done. He uses it to buy food. Correct. So that's kind of like, that's how I know I can split very well. Okay. 1/2 times 1. What's half of 1?
0.5.
0.5. So our coordinate point for Z prime is negative 1.5, comma 0.5. And then G, we have X is 0 and Y is negative 2. So 1/2 times 0 is?
0.
And 1/2 of negative 2?
Negative 1.
Perfect. So then G prime is 0, negative 1.
And then do we plot it?
You can plot it. For the sake of time, I'm not going to do it.
Oh, we don't just need to right now?
Yeah, you don't have
But like usually, do we like plot it and then say like was it a reduction, was it that,
No,
like how?
so I really don't get too crazy about it. I give you a dilation and I give you one coordinate point. Just tell me your new prime. Okay? Okay. Using scale factor to find the length. So if I give you scale factor now, we can take that and apply it to find either a prime value, our ending result, or we can use it to find an original result. And it's ultimately coming down to you're creating an equation and you're solving it. So it says the height of a document on a screen is 20.4 centimeters, which is about, document on a screen. Screens are always diagonal. If you didn't know that, here you go. So they're saying that this distance between this figure or this document on my screen is 20.4 centimeters. That's what I start with. That is when my zoom setting is at 100%. That's pretty normal on a computer. When you bring it up, it should be at 100%. If I took my zoom document, which I don't know if you've ever done, it's right here at the bottom right, and I went down to 25%. It says the document is a dilation of the previous image. That means that the figure is the same. Like you're not changing the document. It's still a document. However, it
25.
shrunk with the scale factor of 0.25. So what is the new image length? Okay, now we can use scale factor to solve. So because the scale factor is 0.25, do we have an enlargement or reduction?
Reduction.
Reduction. If it goes from 100% on the document screen to 25, that kind of should make sense in your head that that is getting smaller. It says a scale factor of 0.25 tells you that the ratio of the image length over the actual length. So scale factor is equal to prime over original. Remember, prime is where you end up, Original is where you started. So if we know scale factor, I can replace FF, SF with my scale factor. 0.25. That is equal to, it gives us a document length. It gives us a document on a screen is 20.4 centimeters.
So that's our original.
That's our original. That's what we started with. When my document percentage was at 100, I measured my document at 20.4 centimeters. So we can replace original with 20.4. Let's call prime P. We're going to solve for him. So I now have this equation. 0.25 equals P over 20.4. Just because I don't want to bend down. All right, Isaiah. Wow. Okay. I created equation. How do I get P? How do I figure out my prom side?
Multiply by 0.25.
Okay, why would I multiply by 0.25? Remember, he's already by himself.
multiply by 20.
Oh.
I want to get P by itself. So I'm going to multiply by 20.4. What I do to one side, you got to do to the other. So my 20.4s cancel. I'm left with my prime. I'm now left with what I ended up with, what I have. 20.4 times 0.25. So my document becomes 5.1 centimeters. Does that make sense? Did it get smaller? Did our scale factor get smaller?
Yes.
Yeah. So should our document have started off at 20.4 centimeters and shrunk down to 5.1 centimeters? No, it shouldn't have.
Yes.
If it's a reduction, it should have gotten smaller. If we got the answer of 50.1, then that's when we'd been like, ooh, there's something wrong. If we would have multiplied by 0.25 and done some all that kind of stuff, it would have been great.
So you put 0.25 equals 5.1.
What'd you say?
Wait, do you put 0.85 equals 5.1 over 20.4? Yeah.
Oh, if you're actually plugging everything in. So, ooh, did you see those cool moves? So 0.25 is equal to your prime. We found that to be 5.1 over your original, 20.4. No, you did not have to do that, but there you go. It's just, I guess it reiterates it. If you plug 5.1 over 20.4 into the calculator, do you get 0.25? Okay. Yes, you do, because that would be really awkward if you didn't. Okay. What? Okay. Okay. Ready? Get your ruler out. I got my handy dandy ruler. It's right here. Don't whack somebody with it. My cool protractor, it's like legit. Okay. So we are going to be able to find dilations by graphing. The first thing we need to do to use dilations by graphing is find center. First thing we got to do, find center.
Center.
No. Center. Okay, we'll get there. Once we find center, we're going to use center to find scale factor. Because if you think back to the problem where we had the coordinate points, where we had P, Z, G, what did we distribute to every X and every Y? 1/2, the scale factor. So we can use that idea knowing that our scale factor gets multiplied to every X and every Y to figure out the scale factor of the problem. Okay, so to find center, I want everyone to put your pencils down. I'm going to write these things up here. Put your rulers down. You see, I hate repeating myself, but it tends to be the one thing I repeat. Finding center. The first thing you must do, don't write this down. I'm just going to talk it out. You're going to use your ruler and draw extended. What's the word extended mean? English moment.
Goes on like it extends past future or whatever.
Yeah, it keeps going. Goes on forever. Don't stop. Well, okay. Stop on a paper, but don't stop between points. We're not connecting the dots. This isn't second grade where you're connecting the dots and you made a dinosaur. Good for you. I know you're a little sad because those are pretty awesome, but we're not doing that. So you're extending a line between image and pre-image is you're going to extend a line from A to A prime, B to B prime, C to C prime, and so on and so forth, depending upon how many sided figure I give you. What? What'd you say? Okay. So let me show you what I mean. I'm going to connect the dots between A and A prime first. So don't judge, this isn't going to be perfect because it's a protractor on a screen, but that's pretty good. That's an extended line. I connected A to A prime, and I kept going. I didn't just stop. I didn't just go A to A. Amen. I'm not drawing a dinosaur here. Now I'm going to draw a line from B to B prime. What was so glorious about that? It's the same line. So if A and A prime, B and B prime, or two coordinate points in their primes are on the same line, you kind of got it nice. I didn't really have to go and redraw that line again. Okay? Lastly, I'm going to connect the dots between C and C prime.
This is where it's been messed up. What?
Nailed it. Now, where all your lines intersect, that's our last step for finding center. Where all lines intersect is center of dilation. Oh gosh. So where all my lines intersected, boom, boom, intersected right here. That is at the coordinate point -1, 4. So my center is at -1, 4. Try it out. Do it yourself. Raise your hand when you get there. Ready, set, go. You're doing the steps I just talked about. I actually want you to try it.
I kind of remember when you were
Yep.
doing
Yep. Yeah, no, you're good. Yeah, right there. And then find it. You're good. Yep. Yep. -1, 4 is where center is, yes. Yep. No, I want you to.
Try it out. So from A to A prime, you want to extend that line all the way.
I actually want you to try it out. Yeah. Lots I don't. I can pull some hair out of my head and use that. I've done that before if I really needed it.
You did that before in real life?
Pull a piece of my hair out and use it as fluff?
Yeah.
Yeah, I have.
Are you serious?
Yes! Why are you, am I weird?
Yeah.
You gonna say yeah? Do you have a question?
There's the weekend.
Yes.
I just worked out too. I realized I was just like
Uh-huh.
so that was
My hair doesn't feel soft.
anything. Is that what you do for your soft hair?
Yeah. I mean, it feels.
So where your lines intersect.
I don't want big wires.
You're trying to prove them similar by AA, which means angle, angle. So you're trying to figure out what two angles are congruent, and how do you know that? You're making assumptions now. We want them to be congruent, and there's a way for us to prove them congruent, but you need to tell me how you know it. Like if you just say A is congruent to E, C is congruent to D, and B is congruent to F, that's great. Yes, essentially. Very, very, no. So,
Dude, you don't want to be.
yes. So the reason why the way that we can use it is the fact that we know that these lines are parallel. If you're trying to figure out, because they're parallel, we can use alternate exterior, alternate interior, same side interior, we can use that idea. So that's where it's coming from. It's trying to be able to just say, okay, I know that these two are congruent because this property parallels. Does that make sense? Yeah, write down 1 and 2, guys.
So, AA is alternate angle?
AA means that you have two angles similar.
Oh, angle is
Okay.
But usually we can you have it in the middle, or it's dumb.
Yes, it
So
is.
different.
It is, I know.
Add a bit.
Just fine, honey.
I don't know, I accidentally
Okay.
So I'm not writing more.
No, it don't.
Lucia, come here real quick. So be closer for C and C prime. Try to get right on top of them.
She literally just did it. So
And then where they connect. You're kind of headed toward A. Do you see where your original line was? You want to go to corresponding vertices. C goes to C, A goes to A.
It's not that hard to
Ready?
do.
So make sure you're just a little bit closer with your accuracy with C prime, okay?
Extend that line.
Coming.
Oh, my nose is.
Wait, the notes right?
Yes. Hi.
But normally she has a thing.
Uh-huh.
in her mouth.
Yes. Jasmine, go ahead and take a break. Do you know where college and career is?
Yeah, a little bit.
Do you want to submit?
By the bathroom.
Yep.
Cat.
Yeah. Miss Denario wants to see you, so go ahead and take your. You'll be coming back. Just leave it. We'll take care of it. All right. I'm gonna move on. You're gonna have more practice with this, okay? So I'm gonna move on. However, I'm gonna stay on this page, and I'm just gonna kind of reiterate what we're gonna be using on this page, okay? So you're gonna keep going on your paper, but I'm gonna stay here because we need to see the graph. Okay. Now, the next thing. The next little thing that you guys have on the next page, it says, don't worry about the asterisk, it's scale factor. So here's my scale factor. I'm staying on this page, you just keep moving. And then it has a big asterisk and then it has a
So we
number.
write what you write on the other page?
Yep, on the other page, because I'm gonna use this photo or this picture right here.
Are we gonna have to use it? Or?
No, you can just follow along here. Okay, so scale factor. How you find scale factor is the first thing we must do. Once the center is found, so center is found, treat like the origin, 0, 0. So we know that center is -1, 4, but we're going to treat it like 0, 0. That's how scale factor works. It's really weird.
The 0, 0 always
I can see that. It's cute.
always.
Now, in order to use scale, or in order to actually find scale factor, we're going to treat center like 0, 0. Then we're going to find the points.
Alright, Pepper. Hey, you be chilling right there on Hobson. No, I seen you all the time when I drive by, chilling in the little front yard right there. Whose house is that?
No.
Of only one vertex. So we're only going to find the point of only one vertex. Image and pre-image though. What I mean by vertex is one letter. So we're either going to find the coordinate points of A and A prime, or B and B prime, or C and C prime. Why does it matter? Why do I only have to use one letter? A,
It's
B,
only
or C?
one vertex.
Okay, well that's because I wrote that. What do we know about scale factor? Think about it. What did you do to P, Z, and G in our example?
You use one scale factor for all of them.
We use the same scale factor for all of them. So why the hell am I going to sit here and find the scale factor for every single one when it's going to be the same thing? So you only have to choose what? Just one. Okay, the next thing you guys have underneath scale factor says coordinate points. So what coordinate point do we want to use? Do you guys want to go to A, B, or C? Which one?
A for Alyssa. B.
Perfect. We'll do A for Alyssa. So we're going to find the coordinate point for A, and we're going to find the coordinate point for B.
You mean A prime?
Oh, sorry. Yeah. Sorry. We're going to find the coordinate point for A, and we're going to find the coordinate point for A prime.
Are we writing it?
Yes. Do you see where it says coordinate point? That's where you're writing it. Okay,
What about the 3?
we're gonna get there next. We're not there yet. So for the coordinate point, you're gonna treat center like 0, 0. That's what it says. So we're gonna treat it like 0, 0, and we're gonna find, how did we go from 0, 0 to A?
1.
We went to what? The right or left one?
Right.
We went to the right one.
0.
Did we go up or down anything?
No.
From center, did we go up or down? No.
So we go right and then up or down.
Yeah.
Right or left.
So it's going to be 1, 0.
You want to sit with him, Jeannie?
Okay. So A is 1, 0. To get to A prime, still treating center like 0, 0, but now I have to go to the right more. We're going to go to the right 1, 2, 3. I went to the right 3. Did I go up or down anything?
No. 0.
So then A prime is 3, 0. Super weird, I know. So treat center like 0 and find the coordinate points from center of dilation, from your origin. So now we have A and we have A prime.
Is the scale factor 1.5?
So the last step, your third step. Use formula and find scale factor.
Is that for coordinate? The last step for coordinate?
Number 3. Yep, number 3. So how we're going to use scale factor. The formula for scale factor equals prime over original. We'll look at it. We have prime, we have original. We have A prime, we have A. Do we use X or Y? Which one?
X, because it comes first.
Okay, but what about Y? Does it matter?
Are they going to be no? Because they're the same.
Why are they going to be the same?
Because we only have one scale factor.
Because you only have one scale factor. Remember when we had P, Z, and G, we multiplied 1/2 to X and we multiplied 1/2 to Y. So 1/2 was distributed to both. So it doesn't matter if we use the X value and it doesn't matter if we use the Y value. You're going to get the same scale factor. So let's use X because, well, why not? What's my prime X?
3.
Over my original X? What's 3 over 1? 3.
So that's the scale factor?
That's the scale factor is 3.
Wait, and the image length?
Yeah.
How do you find the image?
Oh, today I'll make it work. Okay.
How do you find the image, length?
The image length?
Yeah.
Are you talking about the one that we did before?
No, it has image length.
Oh, don't worry about
it's
it.
formulas.
Yes. Don't worry about it. I'm not going to go any further than that. All right, guys. So that's how it's going to work. You have to find center. You treat center like origin. You find your 2 coordinate points, A prime, B prime, C prime. Doesn't matter which one you choose. And then you use X and Y, or X or Y, to figure out your scale factor. Let me give you an example because I know you guys are going to freak out. Oh, freak out. This is like the worst topic to start with, but it's okay. We're going to make it through. There's a lot of hand holding in this topic. So let me kind of give you guys, because the practice today is going to be kind of not so great. I don't know what the best way to say. It's kind of hard to understand. So I want to give you kind of a little bit more examples practicing finding scale factor given 2 images based on the directions that you would see in practice. You can go ahead. You don't mind. So here's practice. So it says the blue solid, a solid line,